Hello and welcome back to a new video. On today's episode of I kinda know what I'm doing, but I probably should have done more research anyway, I'm gonna attempt to cram all these electronics and what's in the bottom of my CNC into this enclosure. That's gonna allow me to have it more accessible and have it protected against dust and chips. If you're interested in that, stick around. So in order for me to move the electronics from the base of the CNC to my new enclosure over there, I'm gonna have to get them out of there. And I don't know if you've seen my last video, but I already regretted putting them under the CNC. Yes, they are somewhat protected from dust, but they're also under this massive CNC. So I'm gonna attempt to get them out of there, and then I'm gonna tell you what new electronics I got and how it's all gonna fit together, hopefully. So the way this is supposed to work is that inside the big box is this metal plate. And onto that metal plate mount these rails. I'm gonna have to cut them down and mount them somehow. I'm still not sure how, but I figure I'm gonna solve that problem once I get there. That is future me's problem right now. This is my new controller unit. It is completely optically isolated, so it uses Ethernet, which is isolated. And it got those breakout points. And the way it's designed is that you can mount it onto those rails somehow, like that. So in order to mount my existing stepper drivers and the UFD, I think, I 3D printed those adapters. So you can see it got the same profile to click on the back here, which hopefully works. Might need some more tweaking or persuasion. It'll work like that. There we go. It does work. And onto those I can mount the stepper drivers, and the UFD fits on here, and this is for the power supply. So now I gotta figure out how to arrange that, and I'm thinking one long rail here for those, one rail for those, and then two shorter pieces for those, maybe longer pieces. I'm not quite sure yet. We'll figure it out. So I guess I'm gonna get started on attaching the drivers to the adapters and the UFD to this one. So I've run into a bit of a problem. The only screws I have an M4, which is how I designed this, have too big of a head, so it doesn't fit in there. So fits perfectly. So that's these three taken care of, the stepper drivers. Now for the spindle controller, I printed this one. I actually kind of ran out of M4 screws, but I got these ones that will also work in plastic. I think they're designed for like drywall, but it doesn't matter, they will fit. Now for the power supply. You can actually buy power supplies that fit this rail standard, but I figured I already own one, so I just printed this adapter and it got holes in the side, so I can hopefully just use zip ties. Because this doesn't weigh a lot, so I'm just going to zip tie that in place and see how it works. I actually only had two zip ties, so I might have to come back to that. But you know, the concept works. Yeah. They kind of grab onto those fins and don't want to let go. That's nice. Good work. So now I can measure how long these rails gotta be and cut them to size. Okay, with that done, I should be able to do a dry fit and see where exactly I have to mount these rails. Okay, so I think this arrangement will work. I got a decent sized border all around the plate, so it should be relatively fast forward to mount it into the big box. So now I gotta mark where these slots are. So I'm thinking I'm gonna do like a drill a hole through it and use nuts and bolts. I think you're supposed to use rivets, but also I have zero clue and I'm just making stuff up at this point. So yeah. Mark it, drill holes, nuts and bolts. Alright, that went together pretty well. Tiny amount of jinx on the back, but that's good enough. Yeah, let's put the parts back and see about wiring. Oh yeah, also I forgot, these are not supposed to be sliding on, you're supposed to click those on, but I think I had too tight of a tolerance here, so it's not flexible enough. If you want those, I'm gonna link them in the notes below, and I'm pretty sure I'm gonna change tolerance. So this is the final layout for the circuit box. I'm gonna go ahead and wire this up. I'm not gonna film that because it's gonna take a long time and it's not really exciting and there's not a lot I can talk about. So I'm gonna do that and I'll see you afterwards. It is now about 2 weeks later. I've been waiting on some parts, I've been kind of putting it off and also been pretty sick, so I actually still am. My voice might crack at some point. But it's done, it's working, it's fully functional, I am very happy. So let me get you in for a closer look and I'll show you what I've done. So all the electronic is above the CNC right now. You got the VFD, the controller, everything we've talked about before. And on the bottom there are the connectors. These are GX20 connectors. I got 5 pins for the motors, because I might swap them out for servos later. Got 3-pin connectors in the bottom for my inductive sensors, which I'm going to show you later. I got 2-pin connectors on that row right there. Those are going to be for sensors and maybe some relay stuff, not quite sure. And a 4-pin connector on the right here, which is for the spindle. This one actually is a GX16, so a smaller one, because I ordered the wrong kind and I have to wait for the right one to arrive, so I'm going to have to swap that out. But it's working. It is not optimal obviously, but I'm going to swap it out. And up there is where the Ethernet cable comes out and goes to the laptop. I also, let me get in here, have an emergency switch. This is connected, but I didn't have the right size drill to cut through the wall and connect it properly, but I have it, so you know, that's good. Alright, let me zoom out and show you what I did on the machine. So on the machine itself I did some more wiring.
I have these. These are inductive sensors, and they are going to function as the limit switches, so they can detect when it comes close without having to touch them. And these mounts are just obviously some made up ones out of scrap wood. I'm probably going to machine some out of aluminum, and since these are right now just glued on with super glue, I am going to screw them into place. But these are really great because now I can home the machine and have a really precise machining position that I can reference from anytime I want. So what immediate advantages did I get out of this upgrade? Well, besides my limit switch upgrade, which I could have done with any controller, I now have full control in Mach 3. So that means I can use all of the great wizards, all the great plugins, all the great functionality that's already built into Mach 3 with my machine. That includes the controlling of my spindle via software. So I can write G-code, like put it to 1600 RPM and turn off and off the spindle, which is great because I can now change RPMs in my code for, let's say, a roughing pass and a finishing pass. Before I would have waited till that line arrived and then change it manually, and it's, you know, if it's hard, you're not going to do it. So now that opens a whole lot of options to me again. And my favorite part so far is this. This is an Xbox controller, and with that I can control my CNC like a game basically. It's wireless, and that's going to be great for rough alignment and fine alignment. And I can also put functionality on all the buttons like macros or homing or maybe an abort button or start stop, all of that. That's just one of the plugins, and you can download for free with Mach 3, and that's something you don't get with those DIY open source softwares, or at least not as easily. That's what I'm trying to get here. So what are the next steps on this machine now? Well, the two biggest projects I'm going to do next, or let's say the two most important projects I'm going to do for it, are one, tool offset probe that's going to be mounted to the table, so I'm going to be able to drive there, go down, and it's going to sense how long the tool is relative to the table. And then another plate that goes onto the workpiece, so I can measure the height of the workpiece and the edges of the workpiece, and that combined with the tool offset probe, it's going to mean that I can have a whole lot of repeatability and precision, even if I have to swap tools in one project or make like 5 or 10 different ones. So I'm really looking forward to that. And that is going to be it from me for this video. Let me know what you think of it. If you have any questions, I would like to try to answer them. I am, as you may have seen, not an expert, but I have read a fair amount, so, you know, my half knowledge might come to some amount of advantage. I don't know, we don't know. We could try it. Other than that, if you're new here, and if you still, after seeing this massive video, figured, hey, I'd like to see more of that, you know, subscribe, like, do whatever basically, I'm not your mom. Yeah, have a good one.